Today we'll see a new topic, perspective projections. So the question is, how is it different from orthographic projections and isometric projections? So in orthographic projections, you see only 2D images. Now isometric projection, the difference is, it's actually similar to orthographic projection. Only difference is in isometric projection, you bring the solid to something called isometric position, where you can see at least three faces of the solid, and because of that you get a three-dimensional feel of the object. So it gives a 3D images. Orthographic projection and isometric projection. Now when you come to perspective projection, now the concept is entirely different. The excellent examples for perspective projection is a photograph. Any photograph that you see is an example for perspective projection. Or in a sense, you can say that all real life images that you see in the physical world that you see is an example for perspective projection. I will elaborate. Now, I'll give you an example, like a very common example. Suppose you're standing in the middle of a rail track. Okay, a rail track, the tracks are exactly parallel. You can see it. They're exactly parallel rail tracks. And you're standing in the right in the middle. And what you see is actually a view like this. The image that you see is something like this. That's a very common image. The rail track, which is exactly parallel, appears to be intersecting at a point at infinity. Okay, somewhere at horizon. So basically, the rail tracks are exactly parallel, but when you stand in the middle of the rail track and look at in this direction, you see somewhere at horizon, you the two parallel rail tracks appear to intersect, and that point is called, actually there is a name for that point. It's called vanishing point. Vanishing point. This is an example for perspective projection. Another example you can think of is, let's say you are entering our college. You are entering through the main gate of our college, and you are looking at the main block. Okay, our main block building. So it looks something like this. So basically, I just need you to focus on these three edges. Okay, these three edges. I'm just forget about the car porch and things like that. I'm just talking about this main part of this building. Okay, so just ignore the car porch part. I want you to focus your attention on these three edges. Okay, these three edges. So in reality, these three edges are equal in length. Okay, but the edge which is nearer to you, you're standing right here looking at from the gate, and you can see that the edge which is nearer to appear to be a bit lengthier than the other two edges. And other one is, I want you to focus your attention on these edges. These edges are actually parallel edges, but they appear to meet somewhere at infinity. Okay, these three appear to meet somewhere at infinity. This is a specialty of a perspective projection. I'll give you a very simple example for that. Let's say you're standing in front of a tall building. Okay, you're this small. This is your size, and you're standing in front of a tall building. So the image that you see will be something like this. Okay, so what I'm going to do is, all right, so if you're this small and you're looking at a tall building, this is what you see. I'll show you a video clip for a clear understanding, and then I'll come back. Imagine you're a small person standing in front of a tall building. So when you look from this particular position, you'll see the building something like this. So all these vertical edges of the building are of equal length. But in the perspective projection, the edge which is nearer to the observer or nearer to the small person that you can see in the screen, that edge appears to be longer than the other three edges. So now that you're clear that these edges, exactly these three edges, which are exactly these three edges are same in length, but the edge which is nearer to the observer appears to be lengthier than the other two edges. And these two edges, which are parallel, okay, to these two edges, the top edges are parallel to the bottom edges, but this edge and this edge appears to intersect somewhere very far away. Okay, so that's a specialty of um, perspective projection. So mind you, I have the first example I have shown you a vanishing point. In this case, you have two vanishing points, one this side and one this side. So it's called actually a two-point perspective. We'll see that in later. So uh, now I want you to consider another thing. I'm not changing the position of the building. I'm just changing the position from which you look at the building. Right now, you're looking at the building from the bottom side. You're looking from bottom to top. Okay, this direction. You're looking in this direction. So that, suppose you climb on another building which is taller than this one, or let's say you climb up a helicopter and you're looking from top. Okay, you're getting an aerial view like this. So when you look at the building, you'll see something like this, right? So right now what you see in the camera is actually a view image like this. So in that case, so this is what you see. Now tell me, what is the difference between these two images? The only difference is you have changed the point from which you look the object. At first your position from was here, now your position is right here. Now that is a specialty of perspective projection. The perspective projection actually depends the point from which you look the object. Okay, if you change the position, it's called station point, the point from which you look the object. You have a name for that, station point. So if you change the position, you get a different image. Okay, now before going into how to draw the perspective projection, you need to get familiar with certain basics. So what I'm going to do is I'm going to show you the basic idea in a drawing, and then I'll show you with actual models and all. I'll explain the basic understanding. You have to be very familiar with the terms that we're going to use in perspective projection. This is just one term. You have another term called picture plane. Then what? Yeah, central plane, horizon plane, things like that. We'll see that. All right. So what you see here is actually very similar to a horizontal plane, vertical plane. But now onwards, in perspective projection, in perspective projection topic, I'm going to name this as ground plane. Ground plane. Similar to our horizontal plane, it's horizontal, uh, and it's called ground plane. Now, this is a ground plane. You have another plane which is exactly perpendicular to the ground plane. It's called picture plane. Picture plane. Similar to our vertical plane. But now onwards, we are going to call it picture plane. Now, imagine that you are standing in front, viewing an object. The point from which you look the object, it's called station point. station point, and this is our station point, and this is our object. Okay, it can be a person or a pole. Let's say it's a pole. As you can see this. So as the line that I have drawn from station point to the extremities of this pole is called visual rays. Visual rays. Okay, so basically from a point the rays emit and go to the extremities, and when you can see that as the rays goes through the picture plane. Okay, imagine the picture plane is a transparent one. You can see in the picture plane an image is formed of this thing, and this is our perspective projection. What I'm going to do is I'll do one thing. I'll just show you a video clip and then come back. Imagine a setup like this. You have an observer observing a distant object. Let's say it's a pole. The red pen that you see is a pole, a post. Okay. Now the observer, in between the observer and the object, you have a screen, a transparent screen. So basically, if you take the 2D image, this is what you see. So you have your observer standing on the ground plane, viewing the object, and while viewing the object, the image is actually formed on the picture plane. So the red line that you see in the screen is actually the image formed on the screen. So this is essence of perspective projection. Now I want you to give you a word of caution. The line that you see in the screen is not actually your view. The line is actually formed because of the point from which the observer looks at the object. Okay, so the line, the red line, the length of the line always depends from the point which you look the object, or the position of the station point. If the position of the station point changes, this person comes here and looks the object, you'll get a different line somewhere here, right? So the position of the station point determines the nature of the perspective projection. All right, now I have changed the view so that right now the camera is actually kept at the point, exactly at the point at the station point. So what you see in the screen right now is actually the exact perspective view. So just to give you an idea, this is our object. See, the red line is your perspective projection. Okay, and you can also see the station point position. So in fact, what I'm going to do is, so this is the red line can see is the perspective projection. I'm going to change the position or position of the object and to keep it very close to the observer. See, now we can see this, the length of the perspective projection has changed. Okay, the length has increased. So this is a very important thing in perspective projection. If the object is nearer to the observer, just like this, you see the object as a longer one or a lengthier one than the previous one. So if you move it backward, see, now the image is gone short, and now it is equal to the image of the perspective projection of the red line in the screen. Whereas if you keep it very close, now it is lengthier than the previous one. All right, so basically we have a position right here. Projection is smaller, whereas if you move it closer, projection is bigger, And if it is on the picture plane, just like this, it will have the same length. Okay, see, the length of the picture, the perspective projection was this in the first case. It increased to this, and then if the object is moved in such a way that it is touching the picture plane, it has the actual length, right? So that's exactly what you saw in the video also. Now, to locate the station point, you need to have two more planes. Now imagine right through your eye a plane is passing like this, which is perpendicular to both the ground plane and the picture plane. Okay, it's passing right through. I'll show a video to give you a clear demonstration, but first I will draw it here and then I'll show you another video clip. So this plane that you see is called the central plane. Okay, so what is a central plane? Central plane, simply speaking, it actually passes through the station point. Wherever the station point, it passes through the station point and is actually perpendicular, exactly perpendicular to the, let's say this is the ground plane and this is the picture plane. And if you're looking from this position, your central plane goes like this, perpendicular to the ground plane and perpendicular to the picture plane, goes like this, right? Now there is another plane which is exactly parallel to the ground plane and passing through the station point. Okay, it passes through the station point, but it is parallel to the ground plane. Now that plane is called the horizon plane. What? The horizon plane. So what is the horizon plane? Similar case. We have a picture plane like this, and if this is your station point, your central plane is like this, and your horizon plane goes through the station point and it's exactly parallel to the ground plane and goes like this through the station point. Okay, so if you look at this setup in the front view, this is what you see. You see the ground plane, as the edge of the ground plane is called ground line, and you see the edge of the horizon plane which goes through the station point. So parallel to the ground plane, you see the horizon plane. So this is the top view of the setup. You have the station point, the screen and the object. And when you look from the top, you see the picture plane is a straight line, the edge of the picture plane, and your central plane actually goes right through the station point and is exactly perpendicular to the picture plane. So when you look from the top, this is exactly what you see. You see the picture plane, the edge of the picture plane as a straight line, and perpendicular to that you have the central plane, and the central plane passes through the station point. Now if the station point is actually somewhere here, your central plane will also go through that point. So wherever is the station point, you have the central plane passing through that point, but it will be perpendicular to the picture plane, right? Got it? Basically, these are the terms you need to know. One is called the station point, other one is called the picture plane, the other one is the horizon plane, the other one is the central plane.